Now we have some notation and some formulas to talk about. First of all, we're still on the same subject, the number of subsets, but I'll use some variable sizes now so you can see the general formulas. The number of subsets of size m from a set of size n, like 1, 2, 3, 4, 5, all the way up to n, is, using the multiplication principle on top, n times n minus 1 all the way down to n minus m plus 1. And then on the bottom, the number of ways of building each set that we need to divide out by, because we only want one of them, is m times m minus 1 times m minus 2 all the way down to 1. Or we could write it using what we now have as some familiar notation. On top is n permute m. On the bottom is m factorial. So here's the terminology. The subsets of size m are called m combinations. Those are just completely synonymous. You could just say subsets, or you can say combinations. And then there's a nice shorthand. This funny looking, it looks like a lot like a fraction there because of the line on the page, but there's no bar, there's no horizontal bar. The fraction is written npm divided by n factorial, but next to it is just n over m without a fraction bar, just parentheses around it. Another way of writing it, just historically two different ways, is n capital C m, and when you see that you read it out, n choose m. The C can be double meaning. It could be n combine m for combinations, or n choose m. C could stand for choose or for combinations. They are said the same way. Then there's some more handy formulas. So we could have a nice formula all in terms of factorial, which can be nice if you're using a computer or a calculator that has those buttons. To get this formula, we multiply on top and on the bottom by n minus m factorial. So on the original fraction was npm over m factorial, but now multiplying on top and bottom by n minus m factorial gives you, on the bottom, nothing new. I just rewrite what I had, m factorial times n minus m factorial. But on the top it simplifies, because npm, if you recall above, multiplied from n all the way down to the n minus m plus 1, but then n minus m factorial starts again multiplying with 1 less than that all the way down to 1. So together that's all just n factorial. Alright, now, so I need to summarize, because there's a bunch of ways of saying the same thing here. Historically, just from various people inventing it, calling it different things, and there being some nice synonymous ways to describe it. So, again, for a set that has n items, u equal 1 through n, for instance, the number of subsets of size m is equal to the number of m combinations of n, just another way of saying it, which is equal to n choose m, a third way of saying it, which is equal to the symbols ncm, or n over m, without a fraction bar, you can tell easier this time, in parentheses, which then you can calculate with these three formulas. You can calculate by starting with n on top, multiplying down to the n minus m plus 1, and the easier way of knowing when you're finished there is that you'll have m terms all multiplied together, and then m multiplied all the way down to 1 on the bottom. Or you could write that faster, npm over m factorial. Or you can write it all in terms of factorial by finding a new denominator by multiplying on top and bottom by n minus m factorial, and you get the formula n factorial over m factorial n minus m factorial.